Hello everyone, I'm Jiawei Xu, a senior software engineer from Alibaba Cloud. Today, I'd like to talk about PolarDB and how we are redefining elasticity with serverless architecture. Today, we will cover three main areas. Firstly, we will start with a general overview of PolarDB, what PolarDB is, and its fundamental capabilities. Secondly, we will dive deeper into PolarDB serverless, exploring its architecture, common use cases, and best practices. Finally, we will demonstrate how PolarDB Serverless provides robust solutions for multi-tenant environments, addressing both write-heavy and balanced read-write scenarios. Let's kick things off with a clear understanding of PolarDB. PolarDB is Alibaba Cloud's advanced cloud-native relational database. It offers extensive compatibility with popular databases like MySQL, PostgreSQL, and even high compatibility with Oracle. This means it delivers the high performance and high availability of traditional enterprise-grade databases, while offering the continuity of user experience and cost benefits of open source solutions. And for scenarios demanding extreme scale, we have PolarDB X, our cloud distributed relational database designed to handle massive data and high transaction volumes efficiently. Central to PolarDB's power is its innovative architecture based on a decoupled compute and storage design. Your applications connect through Polar Proxy, which intelligently handles read-write splitting, load balancing, security, and high availability. The compute nodes, both primary and read-only, share a single distributed storage layer, PolarStore. PolarStore utilizes our customer parallel wrapped protocol for data consistency and reliability. Compute nodes access PolarStore via high-speed RDMA network. This architecture eliminates the need for data replication between nodes, so efficiency is improved significantly. This design enables multi-master capabilities for extreme concurrent and multi-tenancy workloads. Also enables always-on service with an industry-leading 99.995% SLA. And the global database network supports multi-regional deployments with cross-region data synchronization within 2 seconds. Here is a concise summary of PolarDB's core strengths. It's easy to use, offering 100% MySQL and PostgreSQL compatibility. Its instant DDL operations and superior performance. It's incredibly reliable, featuring multi-level high availability with 6 data copies spread across 2 available rooms and full stack encryption. It's highly elastic thanks to PolarDB Serverless for on-demand resource allocation and multi-master for rapid scalability. It's economical, optimizing costs with multi-level storage, high compression engines, and smart SSDs. And it offers deep integration, leveraging high-speed RDMA network, edge-tab compatibilities for both transactional and analytical workloads, and even AI integration through PolarDB for AI. So why trust PolarDB? Our credentials speak for themselves. PolarDB holds the first ranking in the TPCC benchmark, demonstrating record-breaking performance with 2.055 TPMC. That's 2.5 times the previous record. We also achieved this with incredible cost efficiency at just 0.11 USD per TPMC. We also proved number one scalability, simulating 1.6 billion concurrent users and 64 petabytes of storage. Beyond benchmarks, our innovations have been recognized with the Best Paper Awards at leading database conferences like ACM, SIGMOD, and IEEE, ICDE in multiple years. This validates our contributions to push the boundaries of database technology. Now, let's transition from the overview to a deeper exploration of PolarDB serverless. PolarDB serverless is truly an innovation, leading the cloud-native second area by enabling seamless, intelligent scaling with seconds. It offers the ultimate database elasticity. We provide an unmatched scaling range from 0 to 1,000 cores, with zero downtime scaling and flexible hybrid options. This means your database resources perfectly match demand without any manual intervention. The workload and resource relationship scales smoothly, as depicted in the animation. Okay. Furthermore, PolarDB serverless is an enterprise-grade serverless, delivering response time in seconds. It features intelligent resource control, ensuring you only pay for the actual resource usage. And it offers full scenario coverage for diverse workloads without performance degradation. PolarDB serverless offers two distinct models to fit different operational needs. Type 1 is pure serverless. Here, all your computer nodes, both read-write and read-only, are entirely serverless. They scale dynamically, even down to 0, meaning you only pay when your database is active. This model is perfect for highly variable workloads. Type 2 is serverless for provisioned cluster. This is a hybrid approach. You maintain a baseline of provisioned computer resources for predictable workloads, and then dynamically scale locally for provisioned nodes and dynamically add serverless read-only nodes during peak periods. This combines cost predictability for your base load and elastic scalability for burst load. Behind PolarDB serverless is sophisticated technology enabling multi-level scaling. Local scale-up means that faster CPU scaling, hitless buffer reselling, and efficient remote memory pool support. Cross scale-up involves seamless transition based on hot replica nodes, maintaining connection and transaction status across servers. Horizontal scale-out add more nodes, leverage cluster-wide high-performance global consistency, and a hot standby resource pool for rapid expansion. All these are orchestrated by an intelligent decision system, which monitors workload and automatically adjusts computer units in real time. As you can see from the example graph at the bottom of PCU load adapting to QPS fluctuations. Let's visualize the vertical scaling in action. Our serverless management system continuously monitors the workload of each instance. When it detects increased demand, the decision system calculates the necessary resource adjustment. The execution system then rapidly scales the CPU and memory of the serverless instances, drawing from the available ECS resources. All these steps happen within seconds without downtime, ensuring your continuous performance. Scaling between hosts is equally seamless. When read load increases and the existing read-only nodes on their respective hosts have no more local resources for elasticity, the serverless management system initiates a RO node migration. Firstly, a new RO node is deployed on a new machine. This new node is then added to the cluster. Polar Proxy intelligently routes new read traffic to this newly added RO node. Once the old RO node has no more active traffic, it's taken offline. For read-write nodes, if an increase in write traffic triggers migration, a new node is added. Then, leveraging PolarDB's seamless migration technology, transaction sessions and other critical information are synchronized to the new node, enabling a truly non-disruptive migration where transactions remain uninterrupted. A truly scalable database must also guarantee strong consistency. PolarDB achieves this within its strict consistent read cluster. Our read-write node generates a transaction serial number named TSO. The read-only nodes then remotely read this TSO info via RDMA network. The OWL nodes use this info to determine the data visibility for their read-only transactions. This mechanism ensures global strong read consistency for transactions on the OWL node. Simultaneously, PolarDB cluster leverage RDMA network for rapid exchange of buffer pool page metadata and for faster synchronization of read logs. The two mechanism techniques ensure that transaction information is swiftly propagated to the OWL nodes. Such optimizations guarantee strong consistency rates with minimal performance loss. The bottom right graph clearly illustrates a performance comparison between our SCC, eventually consistency, and general global consistency. It demonstrates that SCC, while maintaining transaction consistency, incurs only a less than 10% performance overhead compared to eventually consistency. Another innovation boosting our autoscaling, especially for PostgreSQL, is the online resize of buffer pool. Unlike a traditional database that often require downtime to resize buffer pool, PolarDB PG can dynamically adjust the buffer pool in real time. Our shared memory management model allows granular expansion and shrinkage without performance glitch. As the graph shows, even after numerous expansion and shrinkage, performance remains stable. This means we can optimize memory allocation on the fly without disrupting your application. So, when should you consider to use PolarDB serverless? Here are the most common scenarios. Number 1, periodical peak and valley traffic. Number 2 is expected burst payload. Number 3, protection from burst payload. Number 4, reduce cost scenarios or standby clusters. Let's give some examples. For sharding cluster, we provision independent serverless instances for each shard, enabling auto-scaling based on specific workload needs and simplifying management. In SaaS multi-tenant environments, serverless provides dedicated instances per tenant, efficiently handling fluctuating workloads without manual intervention. For disaster recovery with GDN, standby serverless instances scale up instantly, only when a switchover is triggered, significantly reducing costs for idle standby resources. For unpredictable workloads like e-commerce, serverless instances automatically adapt to a demand with a wide scaling range, minimizing scaling management costs. Periodical workloads, such as development or test environments, benefit from a hybrid deploy model, combining preserved nodes with serverless nodes and for cost-optimized burst handling. Finally, for capacity planning, you can switch between preserved and serverless instances to monitor and validate resource usage, ensuring the best fit a database capacity with flexibility. Now, I'm going to turn off this camera for temporarily to ensure everyone can see the operation demo clearly. Firstly, let's look at how to create a serverless instance or enable the serverless feature for a provisioned cluster. On the PolarDB home page, click Buy Now or click Create a Cluster at PolarDB console. It will jump to the purchase page. Under building type, select serverless to create a pure serverless cluster. You can then choose the DB info, such as PostgreSQL or MySQL, or the version of MySQL. You can configure the serverless special configurations of pure serverless cluster on the specification and proxy page. Minimum PCUs per node. Here, PCU is the resources unit for serverless. One PCU is equivalent to one CPU core and 2 GB of memory. Minimum PCUs per node represents the minimum serverless elastic resources for each individual compute node. If this is set too high, for example, 8 PCUs, each compute node will be allocated 8 PCUs, even if there is no traffic. Maximum PCUs per node represents the maximum serverless elastic resources for each individual compute node. If this is set too low, for example, 4 PCUs, the compute node won't scale beyond 4 PCUs even during peak business. We can directly set it to 32. There is no charge if the resources are not used. You don't need to be worried about the fees. These two settings define the elastic range for a single node. Minimum read-only nodes and the maximum read-only nodes represent the minimum and the maximum number of read-only nodes that can be added to the cluster. These two options control the horizontal scaling range of the cluster. For provisioned clusters, you can create it by selecting subscription or pay-as-you-go under billing type. Then the cluster you created will have a fixed resources. For example, 4 CPU cores and 16 GB of memory. After the creation of provisioned cluster, you can enable serverless feature from PolarDB console. For example, for an existing provisioned cluster I created before, there is an enable serverless option near the cluster topology. Click it. There are several configurations in the page. Their functions are the same with that I introduced in the purchase page. Click OK to enable serverless. We can see the cluster status is set to changing configurations. When the enable task is running, your online business won't be impacted. Just wait for a moment. Okay. If a cluster already has serverless enabled, there will be a button named Serverless Configuration. You can click it to change the configurations. For example, we can change the maximum from 16 PCUs to 8 PCUs. Click OK to apply it. The new configurations will be applied in real time without any impact to your online business. In advanced settings, you can also configure the cluster's traffic detection sensitivity. For example, we can change the maximum CPU resources for elastic upgrade from 80% to 60%. That means your computer node will scale up from CPU ratio when CPU ratio exceeds 60%. Click OK to apply it. Also, this progress has no impact on online business. Also, there is a button named Disable Serverless. Click it and click OK. This will disable serverless feature for the provisioned cluster, and the serverless resources will be withdrawn immediately. Okay, next, let's experience the rapid elasticity of serverless. We will demonstrate this using a pure serverless cluster. I created it, and the cluster is configured with 1/4 to 16 PCUs. We can observe the cluster status on the monitoring page. Select Performance Monitoring and click Compute Node. And the first item is the serverless resources status. Choose last 5 minutes. We can see that the cluster is currently 1/4 PCU, as our minimum PCU is set to 1/4. Assuming we currently have a basic traffic of 2 concurrent requests, let's send 2 concurrent read-write requests from an ECS instance. Let's back to the monitoring page. Refresh the page. We can see that the cluster has changed from 1/4 PCU to 1.75 PCUs. And the CPU ratio is near about 67%. Then we simulate a further active traffic of 2 concurrent requests on ECS. Back to the monitoring page. Refresh it. We can see the cluster scales from 1.75 to 2.75 PCUs. Next, we will simulate a burst traffic peak. Let's stop the 2 concurrent concurrency and set the concurrency to 64 to simulate the burst traffic. Back to the monitoring page and refresh it. We can see that the cluster scales up to 16 PCUs, which is the maximum configuration. At this point, the system has scaled to its maximum configuration, and the CPU utilization is near 92%. The cluster is dangerous as the CPU utilization is still too high. At this time, we can modify the cluster limit in the cluster console. Here we can click Serverless configuration and change the maximum PCUs from 16 to 32. Click OK to apply it. The traffic is still running, we can see. Close. Wait for the configure change finish. Okay, now then back to the monitor page. Select fast 5 minutes. Refresh it. Okay, we can see that the cluster changed from 16 PCUs to 24 PCUs. And the CPU ratio decreased to 66%. Now the cluster is safe as the CPU ratio is high, but not fully unitized. Finally, we stop the traffic and continuing to monitor the cluster status. Let's refresh the status. We can see the cluster begin to scale down gradually every 10 seconds. We can continue to monitor the status, and we will find that it will decrease to 1/4 PCU as the init and the minimum PCU. We just briefly demonstrate the purchase and usage of PolarDB serverless, hoping to give you everyone a clear understanding of PolarDB serverless. Okay, let's continue to the slide. Finally, let's explore a critical application of serverless, providing robust solutions for multi-tenant architectures. SaaS multi-tenant applications often require frequent scaling, but managing many instances can be very complex. Our solution leverages multi-master capabilities to address this. We offer multiple write nodes, providing linear write scalability. Database can migrate between instances in 5 to 10 seconds with no business impact. The diagrams shows how Polar Proxy routes requests to multiple RW nodes. The key advantages include dynamic database placement across nodes, and will support up to 32 nodes. These advantages makes it ideal for high concurrency SaaS or online game applications. Multi-master PolarDB cluster can also be serverless, and all its scaling are in seconds. Multi-master can eliminate single point write anxiety and supporting schema or table or even table partition level write points. It offers vertical scale in seconds, just scale local in the local server with the resources it needed. Cluster can also scale horizontally by adding master nodes or global replica nodes rapidly. This powerful combination of horizontal and vertical scaling, underpinned by our shared storage, enables PolarDB to dynamically adjust write capacity to match even the most intensive workloads within seconds. In conclusion, PolarDB, especially with its serverless architecture, truly redefines database elasticity by combining high performance, reliability, and cost efficiency with multi-level scalability. We have seen how it addresses diverse workloads from peak traffic to multi-tenant environments, providing seamless, intelligent scaling. I invite you to experience the firsthand. Join our PolarDB Always Free program, which offers substantial resource with for both MySQL and PostgreSQL. And for those eager to leverage ultimate elasticity and cost efficiency, take advantage of our 50% off promotion for PolarDB serverless, where you only pay for the actual resource usage. That's all. Thanks for your listening.